Okay, Assalamualaikum and very good morning. So, how are you guys? Hopefully, everyone is in a good condition. So, now we continue our chapter 3 for part 2. Okay, so the part 2 is consists of material and mass balance. So, today perhaps we can cover up to, sorry, 1, 2, 3, 3.2.6 and also 3.2.7. Regarding process classification, operation of process, regarding the balance, flow chart, degree of freedom for 3.2.7 is regarding material and mass balance for non-reactive. Okay, guys. So previous lecture already cover regarding dimension also units. So everybody have done the tutorial and also the focus one. So today we're going to proceed our part 2, which is material and mass balance. Okay, guys. Basically this is sort of like a figure. In this figure, we got process, any operation that cause a physical or chemical changes in a substance. Chemical engineering is possible to design and operate the process for the design, formation of process flow, sheet layout, specification, measure operating variable regarding the operate running day to day. This one is about rate or per time process. Okay, guys. Basically, regarding this matrix and so mass balance, you're going to form a special task, which is this task going to cover what is happening within our process. Okay, so simple. As I told you, previous slide, sorry, previous lecture regarding how you're going to process your products. So here you need to do the mass balance, so material balance. Okay, I think everybody got a few questions. What is material and what is mass? Why it cannot be sorry? Why it cannot be merged become one? Why it is separately teach? So material and mass balance. Okay, guys. Well, we go example regarding your coffee maker, hot coffee. So as I told you earlier, regarding your hot coffee, you need a cup, you need a hot water, coffee powder, you need a sugar. So the material itself is the sugar, coffee powder, and hot water. Meanwhile, for the mass balance, is regarding their quantitative, which is sugar, maybe 100 gram, coffee powder, maybe 50 grams, and hot water, maybe 500 ml. So this is different between method and also mass balance. Okay, next regarding the process classification. Basically, there are three types of process. This one is batch process. Feed is charged to the process and product is removed when the process is complete. Okay, any example of your hot coffee. Once you already complete your preparation of hot coffee, and then you drink the coffee or you consume the coffee. So we call it as a batch process. Here you can see that no mass is fed or removed from the process during the operation. Used for small scale production. Basically is operate in a steady state. Okay. Common use for batch process is your biodiesel plant. Our biodiesel plant is currently operate by using batch process, especially for the trans esterification, also esterification, whereby you need to mix or you need to add on all the material and also the mass of the reactant together, and then you mix it at certain condition, RPM, temperature, pressure, and so on. So after a certain retention time, hopefully your reaction is complete, then you take out your product. Okay, that is your batch process. Next is continuous process. Input and output is continually feed and removed from the process. Operate in a steady state. Used for large scale production. Okay, simple. Continuous ni, okay. Kita tengok macam konsep sungai mengalir, river flow. So dia akan berterusan, right? So kalau you berada di satu point A and you pergi pada point B, dengan harapan mass flow rate sungai tu constant, so we can call it as a continuous process. Proses yang berterusan. Betul kot, saya kot. Okay, sama balik regarding your biodiesel plant. Nowadays, ada a few production biodiesel already use continuous process, which is CSTR, continuous stir tank reactor. Okay, example, continuous biodiesel production is at Pulau Keri under Sendabi. So in there, they are using continuous process. So the third type of process, which is semi-batch process, neither batch or nor continuous. During the process, a part of reactant can be fed or a part of product can be removed. Okay, an example. Okay, tube balloon. So basically, korang akan balloon. Okay, kalau korang contoh Malvina tube balloon kan, at the beginning balloon tu kecil kan. So bila Malvina tiup for a certain while, maybe mungkin 10 saat kot. Trajectory daripada 0 saat bagi 10 saat, dia akan ada pertambahan of mass of air lah. And then dia punya volume pun akan ada pertambahan. Okay, kenapa dia jadi sebagai semi-batch? Sebab at the moment Malvina tiup tu, dia punya volume dia control lah, ikut elastic of balloon. Tapi pada masa sama, kita boleh tiup lagi. So end up, jikalau Mel tiup melebihi daripada balloon tu punya elastic, dia akan pecah, meletup lah. Okay. So operation of process. Sekarang ni ada dua operation, which is steady state and juga unsteady state. Okay, steady state ni dia tidak berubah accordingly to time lah. So let's say kalau macam dia punya volume maybe 500 mil per second. So maknanya every second akan ada 500 mil. Ini boleh tengok dekat dalam piping lah contohnya. So kalau dalam piping tu, theoretically kalau kita kata 500 mil per second, by default sebab fluids punya flow dia ada disturbance, so dia akan ada tolerance lah. So maybe 500 mil per second plus minus 20 mil, macam tu contoh example. Tapi kita boleh assume lah dalam piping tu fluids yang mengalir ialah steady state. Maknanya daripada point A pada point B, di point A pun 500 mil per second, point B pun 500 mil per second. So meanwhile untuk unsteady state or transition, proses ni variable change with time. Okay, contoh macam tadi, Mel tiup balloon. Tiup balloon. Tiup balloon lah. Okay, first tiup, katalah dia punya speed ialah 10 mil per second contoh. Adakah second tiup dapat 10 mil juga? Teorinya tak kot. Sebab Mel ialah manusia and then dia bukan mesin, dia tak nak control dia punya flow rate. So it becomes unsteady lah. Okay, now kita pergi test yourself. Define type and operation of process given below. Okay, a balloon is